video tutorial of hydrology tools in Chapter 3 of the Advanced GIS textbook. In this step, we're going to extract a topographic profile along the Spanish Fork River watershed polylines that we've created. And so to do that, basically, we need to kind of separate out what that profile line is that we want to analyze, because there's a lot of lines here. We don't want the topography of all of them, just the trunk stream in this case. We could do any one, but I want to get the main Spanish Fork River, which turns out is an interesting question. Didn't quite realize this, but as we follow the Spanish Fork River upstream, the first major tributary we get to is called Diamond Fork River. And I thought, well, which one of these is Spanish Fork River? Turns out this one on the south is called Thistle Creek, and over here is called Soldier Creek. And so there is not, and this one is not Spanish Fork. So there's actually no Spanish Fork River once you get past this weird junction down here where the Thistle landslide and lake occurred. But we'll follow the kind of the river that goes to the highest topography, which is this Soldier Creek. And so I'm going to follow it from the mouth upstream. And then as I get to here, I have a choice, like, what's the main thing? Well, it's this area, but this doesn't go to as high of topography. So I'll bend up and come out onto this kind of high plateau, the Wasatch Plateau up here. Okay, so basically what I need to do is select the stream here. And so I'm going to go into select, and then I'm going to create this thing, add to current selection, as I click. Okay, so it's each time I click, I'm not creating a new selection. I'm just adding to what I got. Okay, so if I click select then, and I select the line, you can see that I've got this line segment. And then the next one, click, click. Oh, gotta be careful there. Don't want that. I clicked on the watershed. How do you solve that? So now I'm going to remove from current selection. Get rid of that watershed. Okay. Go back to add to current selection. Okay. Now we can go up here, list by data source, list by selection. We can turn off things that we don't want to be selecting. So we can't select them. Okay, good. Now if I click over here, it doesn't select the watershed. Good. Okay, so this is all helpful. So as we do this clicking to select this river line that we want to profile, we need to be careful not to get the side tributaries, and then also to make sure that what we're selecting actually links up, is connected continuously. When I made this line, was pretty careful to like simplify it, because that was going to make this process easier. So now I've gotten to almost a Diamond Fork. This is kind of a tedious process, right? You can do it from a little ways out. You have to be careful not to miss anything. Sometimes you get these little interchanges where there's like 1 pixel and you missed it and then fails. It's really annoying. But with a simplification, doesn't look like I have a lot of that going on. Okay, so I want to go up over here. And then I have to be careful here. You sometimes get these weird river lines in these floodplains. Like this is this area of impoundment behind the Thistle Dam that happened with this big landslide in the 1980s, and it flattened out the topography in here quite a bit. So we have like parallel flow accumulation lines here. I don't want that one because it doesn't go anywhere, so I got to get this top one. Got it. So it's putting the channel over on this side. That might not be true if you looked at the LiDAR, but that's what it is in the ALOS DEM. So sometimes you have to zoom back out to make sure you're following the right channel. I'm a little bit confident, but don't get overconfident. And you want to be careful. I want to go all the way up here. Okay. Okay, so here's something I need to be careful of. There. I could have missed that. Like if I had clicked this, I might have missed that one. So this is another reason, if you were going to do this topographic profiling, to not have a lot of extra streams, because the more stream junctions you have, the more of these lines you have to click and add on to, because each stream segment's kind of between these junctions. So keep that in mind. Now here I have to be careful again. So I click here. Yeah, I could have missed that. And I don't really want to click in opposite order. I feel like sometimes that creates an issue. Get them as they go upstream. Okay. So now I want to go up on this high area here. No, I actually want to go further and then up there. Okay. Trying to get the longest stream path to the highest topography, just to see what the watershed looks like overall. It's done. Not bad. Getting up onto the plateau, and there it goes. Okay. So I got that stream. Now we can do a couple of things. So that is, go back over to the main thing. So those streams are in this area here. So I can right click, I can export those features, just the selected ones, and I'm going to call that Spanish Fork, Soldier Creek channel. So I turn off all the other ones. There it is. Okay, so we saw that it had segments. We may find that as we do this topographic profile that that creates some issues, but I'm not sure it will. Sometimes next step would be to like dissolve this into one line, but I'm not sure that's necessary. So let's do the next thing that we need to do, I believe, is to create an elevation layer. There's actually many different ways we could make topographic profiles. And I'm not going to go through all of them in this video, but there's a way to use 3D analysts to basically intersect a line with a raster and extract a profile. That's one way. Um, uh, there are others, basically to give your line elevation data, like basically along every so many meters, you could attach elevation data, and then you could like right click and plot. You could create a chart and a profile graph from that. That's another way. But I'm going to show you something different. Okay. So what we're going to do is we're going to go to add data. We're actually going to add data that we already have in here. We have elevation data from the fill DEM. And we could use that, and I might, but when we do this, what we're going to do is add elevation source layer. And it's a little frustrating because it's not going to just default to like, oh, what are my elevation source layers that are open? It's actually going to make you look through your folders to find it. And so I'm in chapter 3 example, And actually, I'm going to go back. No, I'm going to go in there. And then in there, I have the projected raster of the ALOS 30 DEM. I'm going to use that one instead of the filled one, the one that's open, which is called fill SFWDM, which would be that one. I'm going to use the original one because I don't really want filled holes. I want to see what the actual river profile looks like in case some of those holes were in the river. So, okay, so that's my elevation ground surface has shown up here. And incidentally, you can profile any raster by adding it as an elevation surface. And then doing what I'm going to do next. Okay, so next I'm going to go to analysis and this tool right here, which is called exploratory 3D analyst. I want to make an elevation profile. And you can do this by interactively placing things. Like if I'll just show you an example. So if I interactively make a line across here, it'll give me a topographic profile, or you can see how those ridges go. See that again. Oh, when you do that, you need to like use the unit of the map. But for example, like we could go up and over this mountain here, Santaquin Peak. You see it goes way up. There's a high summit, another summit, etc. So that's one option, but what we want to do is do it along a line that we already have, and we have that line layer, which is the Spanish Fork Soldier Creek Channel. It's not selected. Okay, so right click, selection, select all. Selected, now we go along the line and click apply. And so hopefully this works. You see it did not complete things, right? So it went down to a point from upstream, downstream, and then it stopped right there. Look, I left a gap. So there's a couple of issues. So if I turn back on my other streams, you can see I made a mistake, right? I need to close that gap. Okay. So I can do that. And you probably run into this issue as well. So I could go back and add it in, but I'm actually going to cheat. And this is a little problem, like this is problematic if there's directionality here, but I'm just going to edit, create, click here, and I'm going to go from here to here. Okay. And save. Okay, so now let's see if that solves the problem. Go back to analysis, exploratory 3D analyst. I need to select the whole thing again. Long line, apply, see if it works. Oh, look, I got most of the way there. Got a similar problem. So I got overconfident clicking. Okay. So now I go back to edit again, create. Save. Yes. Okay. Analysis. Analysis. And then select all again. So we're not just doing that point. And now it's got selected the whole time. Okay, cool. So that's kind of neat. So it shows you the river profile as you go from all the way up here on the Wasatch Plateau. You can see there's a different kind of slope here. And once you get over that edge, it kind of becomes more concave and maybe changes a little bit in here. Then it steepens a bit again right here, like flattens off and then steepens again as we go down into here. There's some weirdness in here. That is near where that Thistle landslide is. So I'm not sure exactly that is. It looks flat. Looks like okay to me, but looks kind of funky for whatever reason. And then it goes on. So that's a river profile. Okay, and I should have done this before, so let's exaggerate it a bit. So we'll look at the whole thing again. Okay, so yeah, so I guess a kind of maybe major takeaway here is like, what do topographic profiles along rivers look like? So you should expect them kind of to look like from here down to here, kind of this concave, kind of smooth bowl shape. Whenever you have these undulations, like it switches from being concave to kind of convex, we call those nick points or nick zones. If it's a nick point, that really means it's like a waterfall. So there's usually better to call them nick zones. And so here we're actually going up to different parts of the landscape. So we're going up onto that old topographic plateau the river is. And so actually the river up here, it hasn't felt this wave of incision that kind of has cut through the rest of the landscape below the plateau. And so that's why it looks so different. The river is graded to a different concavity, it's called. And so this is like almost like a relic river of the plateau. It is connected, but it looks very different than the rest of the river topography. And so I see another nick zone here. It kind of sense, if we look at where that lies up above, it's kind of like here where you're going through this high topography. Something geologically is probably going on there. Also, maybe there's a nick zone down here. It's hard to tell because of all these frustrating bumps, but that's because of the landslide, most likely. But there's actually also, we get a bunch of tributaries coming in. And so sometimes we get nick zones where rivers come in like that. And so that makes sense. And then it does, the grade does change again as we get down here to the bottom, which might have something to do maybe with like the fact that you're going out into the valley and like the area that maybe was influenced by Lake Bonneville and the Wasatch Fault more recently. And so some of these changes in the shape of the river profile we can attribute back to either human action, rivers, changes in rock type, or different areas of geologic process. Okay, so that's how we create our river profile. If you wanted to export that, we can export it as a table that we could bring into another program and graph another way. You can also export the image, not as effective. It's not the prettiest image that they produce for you. This exploratory 3D analyst tool is the way that I like to profile in ArcGIS Pro because it shows you where you are along the profile as you scroll along it. So I think that's the best way to go about it. Like I said, you can find some other tutorials online for other ways to do it, but this is probably the best. Okay, so that's video 5 and step 5 for hydrology tools. Obviously, there's way more in the hydrology tool set that you could do. So if we go back in there and just look for a minute, there's other things like you could calculate the stream order So like if you've taken a geomorphology class, you know that the more streams that join to a stream, it becomes like higher order. And so that's a way to like kind of classify streams, things like that. You could kind of do even things like potentially try to like model flow or locate things along the river as a route, things like that. There's more to that toolbox, but this is all we'll do for these video tutorials for now, and it will help you complete Lab 3 for sure. Okay.